Hi guys, good morning. Can you hear me? Hello. Yes guys, good morning. Can you hear me?
Yes, good morning, sir.
Yeah, thank you. So we'll start session. So last class about basics discussed. Yeah, let me open up my last class document. Yes, last class. Yeah, these basics that initial topic discussed here. Yes, about system software, application software. Next about OS discussed. Next about front and back end discussed. Language packages. Next low level, high level languages. These topics are completed in the last class. Okay. Yes. Today topic is about interpreter and compiler. See, last class, last topic, interpreter or compiler convert from high level language to binary code. So this topic discussed in the last class. Okay, interpreter or compiler. So interpreter or compiler convert from high level language to binary code. So interpreter or compiler convert from high level language to binary code. Yeah, this topic discussed. Okay, this topic discussed in the previous class. Yes, what is interpreter? What is compiler? Let us see. So both are converting from high level language to binary code. Both are to convert from high level language to binary code. But some difference. What's the difference here? Interpreter versus compiler. Yes, let us see about this topic. Interpreter versus compiler. What's the difference? Yes, interpreter versus compiler. Yes, today topic is about interpreter versus compiler. Okay, so once you understand this one, we'll move to Java. So interpreter versus compiler. Okay, let's So yesterday, just introduction, the basics about voice, cleared, about system software, application software. Next about voice. Okay. Yes, next about low level languages, high level languages. Okay, low level, high level languages. So these topics completed. Okay, yes. Today topic is about interpreter and compiler. Okay, so interpreter or compiler converts from high level language to binary. Yes, interpreter versus compiler. Today topic is interpreter versus compiler. After finishing this one, next we'll move to Java. We'll start Java. So with these basics done, completing here. So with that finishing basics, next we'll move to Java. Okay, let us start. Interpreter versus compiler. So what is interpreter? What is compiler? Let us say about first of all about interpreter. Interpreter. For interpreter, I'm taking Python scripting. Python scripting. So what does that do? Python scripting. Does that do? Python scripting. Python scripting. Okay, Python scripting. Yes, how Python scripting is working. Let us see. Okay. Yes. See, Python, to develop the Python applications, Yes, to develop the Python applications, we have the PyCharm IDE. Okay. Now here it's a very simple program. We are going to discuss simple script, very small script. So for this PyCharm is not necessary. Let us start. Let us go with Notepad. Let us try with Notepad. How Python script is working. For easy understanding, better take Notepad. So Notepad. So for example here, suppose Durga folder. Yes, Durga folder. Yes, in this developing one script, small script. Let us see small script here. Yes. So command prompt, at the command prompt cmd, command prompt, open command prompt, yes, equivalent D drive, yes. From D drive, go to Durga folder, cd Durga, changed, cls, yes, dir. So test ws. Yes, all right, say here. This now here, let us see some Python script for this notepad. Just notepad test.py. Okay, test.py. See, these are already existing. Some directories are leave it. That is not necessary for us. Zero files, no files. Now notepad test.py. So py is the extension for the Python. Notepad test.py. Yes, open that notepad. Yes, create a new file. Yes, very simple script here. Yes, a equal to 10. Yes, a equal to 10. Yes, b equal to 20. B equal to 20 here. Yes, here script to add, subtract, and multiply two numbers. Script to add, addition, subtraction, and multiplying two numbers. C equal to a plus b. C equal to a plus b. Yes, print. Yes, addition. Yes, addition. Yes, addition. Addition is equal to displaying C value. C equal to yes, a minus b. A minus b. Yes, print. Yes, subtraction is equal to C, displaying C value. C equal to yes, A into B, A into B. Yes, print multiplication. Yes, multiplication is equal to displaying C value. Right? So A equal to 10, B equal to 20, C equal to A plus B. Addition, displaying C value, A minus B. Yes, subtraction, displaying the subtraction value, A into B multiplication. So simple script, very simple script. How the script is working? Let us see. Save, Control S for save, and close Notepad. Now, yes, now running the script. Yes, Python. Yes, directly running script. Directly running script here. Yes, directly running. So you can directly running the script here. Okay. Yes, 1 second. Suppose if C program, first of all, you have to compile. C program, you should compile. Other programs you have to compile. But in case of this Python here, no comparison, directly execution. The script executing directly, executed directly. Suppose any error comes, what happens? Any errors. Suppose here some mistake. Okay, suppose here one more mistake. Okay, some errors. Totally 3 errors. In this program, totally 3 errors. Save and exit. Now run it. Yes, Python. Yes, test.py. Run it here. See this. What's happening here? Yes, this statement here error started. So what is happening? It's not showing all the errors. The Python interpreter is not showing all the errors. So only first error showed. Only first error here. It's a first error. So what is happening? Let us see what is happening. Yes, let me explain clearly what is happening here. How interpreter is working. Let me explain clearly here. Let us see how interpreter is working. See interpreter. See first line, statement. Okay, next statement. Okay, next statement. So next statement. The scripting statements. Next statement. Yes, next statement. Statement like for example here. Yes, in our case, script A equal to 10 for statement, B equal to 20, C equal to A plus B, print. addition, yes. Next, C equal to A minus B, yes. Printer, yes. Subtraction, C equal to A into B, yes. Print multiplication. So these are the statements. They are the statements. They are the statements, right? Yes. How this interpreter is working, how this Python interpreter is working. Not only Python interpreter, any interpreter working is same. Any interpreter working is same. Any interpreter working is same, no difference. Any interpreter working is same. So any interpreter working is same. Okay. Yes. How that interpreter is working? Let me explain one by one here. Okay. Yes. Yes. See, interpreter first of all checking for the first statements. Interpreter checking for the first statements. Suppose first statement is correct. Interpreter checking first statements. Suppose first statement is correct. Interpreter converts this first statement into binary codes. This statement into binary codes. Zeros ones format. Zeros ones format. Converts into binary codes. If the binary codes given to processor. Binary code given to processor. So processor generating output. So interpreter checking for the first statement. Interpreter checking for the first statement. First statement converting to binary codes. The binary code given to processor generating output here. Okay, right? Yes. Next. Checking for next statements. Checking for next statements. Suppose next statement also correct. Simply converts into binary codes. See here. Interpreter checking for the first statement. Interpreter checking for the first statements. First statement. First statement is correct. Simply converts into binary codes and generating output. See, next coming statements may be right or wrong. See, next coming statements are right or wrong. So interpreter never think about next coming statements. Interpreter never think about next statements here. If statement is correct, if that statement is correct, immediately converts into binary code generating output. So checking for next statement. Suppose next statement also correct, same converts into binary codes. Same converts into binary codes and generating outputs. So next statement also correct. Simply converts into binary code, just converts into binary code and generating output. Converts into binary code, generating output here. Okay, right? Yes, checking for next statements. Checking for next statement. Suppose something wrong here. Next statement, something wrong, simply stops. It won't go for next statements. It won't go for next coming statements. So interpreter checking for the first statement. If it is correct, then checking for next state. Yes, first statement is correct. Immediately converts into binary code generating output here. Second statement correct. Converts into binary code generating output here. Next statement, something wrong with next statement, simply stops here. Stops. So interpreter will not go to next line here. So it won't check for next thing. So if any error comes, interpreter stops. Any error comes, interpreter stops. Okay. So checking first line, then execution. Checking next line, then execution. So line by line. So interpreter executing the script line by line. Interpreter executing script line by line. Line by line. First statement correct, executes. Next statement correct, executes. Checking then execution. Checking then execution. It's a line by line. Interpreter executing script line by line. Checking for yes, script line by line and execution. First line checking, then execution. Next line checking, then execution. So next line checking, any error comes, simply stops. So if any error comes, interpreter stops. Any error comes, interpreter stops. This is working of interpreter. Okay. Yes. Next about compiler. How compiler is working here? So let us say about compiler. Okay. Same thing. Yes. Compiler. Yes. Compiler. Yes. For the compiler, let us take some C language. For compiler, let us take C language. Yes, compiler. Yes, for C program. Let us take C program. Okay. Yes. Support test.c. How it's working. How it's working here. Okay. See here. Compiler. Compiler checking for the first statements. Compiler first of all checking for the first statement. Suppose first statement is correct. Even correct, it won't convert into binary code immediately. No, it won't convert into binary code. It won't convert into binary code immediately. Then checking for next statement. Suppose second statement also correct. Even correct, it won't convert. Checking for the first statements. So first statement is correct. Even correct, it won't convert. Yes, second statement checking. Even correct, it won't convert. It won't convert here. Okay, then checking for next statements. Checking for next statement. Suppose next statement something wrong here. Error yet some line here. Error at third line here. Error at third line. After that, checking for next statement also. Checking for next statement also. Next statement also correct. Then checking for next statements. Checking for next statements. Next statement also correct. Then checking for next statement. Like this, compiler checks the whole program from top to bottom and shows all the errors. Something wrong here? Yes, error at some line here. Error at some line. Checking for next one. So checking for next something wrong here. Error at some line. So compiler shows all the errors from top to bottom. See, interpreter is only one line checking here. So only one line. So line by line. Interpreter is line by line. But compiler is not like that here. Compiler is not like that here. Compiler, it checks the whole program from top to bottom. Compiler checks whole program. Compiler checks whole program from top to bottom and shows all the errors. Compiler checks whole program. Compiler checks whole program from top to bottom. Compiler checks whole program from top to bottom and shows all the errors. It shows all the errors from top to bottom. Okay, so compiler checks the whole program from top to bottom and shows all the errors in the program here. Let me show C program example. C program. Yes, C program. Suppose here this is the main function. Yes, save. Compile. C program. See this program or same program. See add, subtract, multiplication of two numbers. Same task this also. Addition, subtraction, multiplication of two numbers. So this is C program. Addition, subtraction, and multiplication of two numbers. Addition, subtraction, and multiplication of two numbers. Addition, subtraction, and multiplication of two numbers. See, compile, success, no error, run it. Yes, first number 10, second number 20. Yes, addition 30, subtraction minus 10, multiplication 200. Addition 30, subtraction minus 10. Yes, multiplication 200. That's it here. Suppose now let us see with some errors what happens. Suppose any mistakes, what happens here? Suppose here some mistake. Here semicolon missing. Suppose here some bracket missing. Okay. Suppose here some comma missing. Comma missing. Okay. Suppose here semicolon missing. Okay. Yes. Suppose here some bracket missing. Let us see here what happens here. Suppose here semicolon missing. Yes, here this bracket missing. Yes, now save it. Saved. 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 Yes, overwriting. Yes, compile. Now compile it. Yes, errors. See, 8 errors. Totally 8 errors. Saying that there are 8 errors. 8 errors. Press any key. See that. 16th line error. Next 18th line error. 22nd line error. 27th line error. Yes, 29th line error. 31 line error. Yes, 38 line. Yes, 40. Like this. All the errors from top to bottom. Compiler shows all the errors from top to bottom. Compiler shows all the errors from top to bottom. Compiler shows all the errors from top to bottom. So here, how compiler is working? See, so compiler checks the whole program from top to bottom. Compiler checks whole program from top to bottom. So compiler checks whole program from top to bottom and shows all the errors. It checks all the statements from top to bottom. Compiler checks all the statements. Compiler checks all the statements from top to bottom. Compiler checks all the statements. Compiler checking all the statements from top to bottom and shows all the errors. Compiler shows all the errors from top to bottom. That's it here. Now let us correct all the errors here. Let us correct all the errors. Correction of all the errors. See here. Yes. Next here. These errors. Let us correct all the errors here. So first semicolon here. Yes. Next here bracket. See. Yes. Next. Comma. Yes. Next. Semicolon. Yes. Next. Those brackets. See, save. Yes, overwritten. Yes, compile. See, there are still 2 more errors. See this. Yes, semicolon missing. Right? Semicolon missing. Yes, compile. Errors. 1 more error. So you have bracket missing. Yes, save. Overwritten. Yes, compile. See this. No errors. Success. Yes, if no errors, what happens? Let us see. Yes, here no errors. So checking for all the errors from top to bottom. Checking for all the statements from top to bottom. Okay, checking all the statements from top to bottom. Suppose no errors, everything is fine. Everything is fine. Everything is fine. So everything is fine. So no errors from top to bottom, everything is fine. Then what happens here? Yes, compiler checks whole program from top to bottom and shows all the errors. Suppose if no errors, if everything is fine, if everything is fine, then what happens? If everything is fine, if everything is fine, then what happens here? Then what happens? Then compiler opens another file. Compiler opens another file. It opens another file. Compiler opens another file. After opening another file here, this whole code converts into binary format. This code converts into binary format. First line converts into binary format, zeros ones formats. Okay. Next second line converts into binary format, right to another file. This whole code converts into binary format. Whole code converts into binary formats. Whole code converts into binary formats. That whole code converts into binary formats and write to another file. And write to another file. Compiler checks all the statements from top to bottom. Compiler checks all the statements from top to bottom. Top to bottom after checking if no errors. If no errors. If no errors, this whole code converts into binary format and write to another file. Write to another file. This file is called as exe file. This file is a exe test.exe file generated. That's it. So compiler checking for whole program from top to bottom. Suppose if no errors, generating one exe file. This whole code converts into binary format and write to one exe file. Exe means executable file. Exe means executable file. Executable file. That exe file. Yeah, that exe file given to yes processor. So processor taking that exe file, generating output, generating output. That's it. That exe file given to processor. Now processor generating output. That's it. Okay, this is what is happening with compiler. Let me show that. See here. So program compiled. Okay, fine. Yes, let us see backend of this program. Backend. C drive. Yes, Turbo C. That C software installed it Turbo C in Turbo C bin. Inside of bin, all programs here. Yes. What is this program? Math.cpp. Here it's a math.cpp. Math.cpp. So math.cpp. See this math.cpp. Yes, this is 1 second. Let me remove some files here. Delete. Yes. Delete. Delete. Yes. See here. So compile. Success. Okay. Success. No errors. So this is our backend program. That math.cpp. The program in the backend. Addition, subtraction, multiplication of numbers. Okay. Yes. Now this one. Yes. Run it. Now run the program. What happens? Run it here. Run it. Once run it here. Backend. Some application math.exe file generated. Properties. .exe. .exe. That exe file created. See that exe file. If no errors, compile checks the whole program top to bottom. If no errors, generating one exe file. Generating one exe file. It will generate exe file. Okay. Generating exe file. Okay, it will generate one exe file. It will generate exe file. Generating exe file. Okay, that exe file generated. Now exe file executing here. Exe file executing. Enter first number. Let us say 10. Second number 20. See that addition, subtraction, multiplication. That's it. Addition, subtraction, multiplication. That's it. Okay, that's it here. Okay, 1 second. Right. Okay, fine. 1 second. So compiler checks the whole program from top to bottom. If no error, generating one exe file, that exe file executed. See that backend exe file generated, right? Backend, see this exe file. This exe file executed. That's it here. Okay. Yes. Now, what's the main difference observed between interpreter and compiler? See this interpreter. See interpreter and compiler. So between this, what's the main difference of that here? See this exe file, right? Yes, this exe file. Yes, in compiler exe file, right? But interpreter don't have exe file. Yes, main difference between interpreter and compiler. Yes, compiler generates exe file, interpreter does not generate exe file. Interpreter don't have the exe file concept. Okay. Yes, let us see. Yes, the differences one by one. The differences. See interpreter versus compiler. Interpreter versus compiler. Interpreter versus compiler. See interpreter. Yes, interpreter, it checks the code line by line. It checks the code line by line. It checks the code line by line. Checks the code line by line. Okay, interpreter checks the code line by line. Interpreter, it checks the code line by line. Okay, interpreter, it checks the code. Interpreter checks the code line by line. Code checks the code line by line. Yes, compiler. Yes, it checks whole program from top to bottom. It checks whole program from top to bottom, right? See interpreter. So interpreter compiler difference. First difference, interpreter checks the code line by line. Interpreter checks the code line by line. Interpreter checks the code line by line. Compiler, yes, it checks whole program from top to bottom. Compiler, it checks whole program from top to bottom. Okay, interpreter checking code line by line. So one by one line, first line checking, then execution. Next line checking, then execution. Only one line at a time here. But compiler what happens here? Checking whole program from top to bottom. Checking whole program from top to bottom. Checking whole program from top to bottom. Okay, right? Yes, next. Yes, output. When come to output here, interpreter. Yes, output line by line. Yes, it generates output. Interpreter generates output. It generates output line by line. Generates output line by line. It generates. Interpreter generates output line by line. Yes. See, in case of compiler, what happens here? Exe file created, right? In case of compiler, exe file created. See that exe file created. That exe file executing at a time. So output is at a time. That exe file executing. So at a time executing, right? That exe at a time. So at a time output here. So at a time output. Okay, so compiler generates output at a time. Compiler based program, the exe file executes at a time, generating at a time output. Okay, right? Yes, next one more thing here, one more difference. Interpreter shows only one error, right? Interpreter only one error. See that? Interpreter. Yes. See interpreter. Yes, Python. Yes, test.py. Let's skip see that error, right? Only one error. Okay, now let us correct this error. Notepad. Yes, test.py. See. Now let us correct this error. Yes, error. Yes, after correction. Now submit here. Yes, next error. Next. So whenever error comes, it stops here. So next error. Only one error. But compile is top to bottom all the errors. So next error. So this missing here. Save it. Yes, after correction. Now run it here. Yes, next error, right? So this is showing only one error. Okay, it is showing only one error. Showing only one error. Okay. Yes. Right. Yes. Now run it. If no errors, program execute. Yes. Sorry. Yes, addition 30, subtraction minus 10, multiplication 200, 30 minus 10, 200. That's it here. Okay. So if no errors executing, right? Okay. Yes. So interpreter shows only one error. Interpreter shows only one error. Yes, it shows only one error. It shows only one error. Okay. Yes, interpreter shows only one error. It shows only one error. Okay, 1 second. Yes, interpreter, it shows only one error. Interpreter, it shows only one error. Yes, compiler, it shows all the errors. Yes, it shows all the errors from, yes, top to bottom, from top to bottom, all the errors from top to bottom. Okay. Yes, interpreter, it shows only one error. Interpreter, it shows only one error. It shows only one error. Compiler, it shows all the errors from top to bottom. Compiler shows all the errors. It shows all the errors from top to bottom. That's it. Next important main difference. Main difference EXE file, right? Main difference EXE file. See, interpreter, it generates EXE file, it generates EXE file. Yes, interpreter generates EXE file. Compiler, it does not. Sorry. Interpreter, it does not generate EXE file. Interpreter does not generate EXE file. See this. Here, what we discussed. So here interpreter, no exe file, line by line executing, just line by line executing, compiler generating exe file, right? Compiler generating exe file. So the main difference here. So here, so yes, interpreter does not generate exe file. Interpreter does not generate exe file. Compiler, yes, compiler, it generates exe file. Generates exe file, generates exe file, generates exe file, generates exe file. See here, interpreter does not generate exe file. It does not generate. So interpreter does not generate exe file. Compiler generates exe file. These are main difference. Fourth point is the main difference. So what's main difference between interpreter and compiler? Exe file. Interpreter, compiler, main difference exe file. So interpreter does not generate exe file. Compiler generates exe file. Okay. See, in case of interpreter, what is happening here? The source code, see, this is source code. Python source code, right? It's a Python source code. Python source code. Here, the source code executing directly. That code executing directly. Okay, so interpreter executes source code directly. Yes. In case of C language, compiler, what happened here? See this. Now run it. When you try to run it, it creates one exe file. Okay, see this. That math.exe file. Now again generate it. Recreate exe file. 841. Regenerate it. 8:41 AM. Just now. 9/7. So 9th July. 9th July 8:41 AM. Just now that exe file created. Exe file generated. Correct? I enter first number, second number. Yes. So exe created, then executed, right? So exe will execute exe file. See, interpreter. Yes, it executes source code directly. Yes, interpreter, it executes source code directly. Okay. Yes, interpreter, it executes source code directly. So what is compiler here? Yes, it executes exe file. It executes exe file. Okay, right? See, interpreter, it executes source code directly here, executing source code directly. See, this source code executing directly. No exe file. See this, check it. tr test.py. Only we have the file test.py. That Python scripting, only scripting here. Only script is right. No exe file, no .exe here. That script executing directly. Here. Script executed. But in case of compiler based, what happens? It executes exe file. It generates one exe file. Yes, it generates exe file and executes that exe file. That's it here. So this is main difference. Fourth and fifth point, they are main differences. So interpreter does not generate exe file. it executes source code directly, but compiler generates one exe file and executes exe file. It generates exe file and executes exe file. That's it here. Okay. Yes. See, interpreter-based languages are called scripting languages. Scripting languages. Interpreter-based is a scripting languages. Interpreter-based is a scripting language. So compiler-based called as programming language. They are programming language. Okay. So interpreter-based is a scripting language. Compiler-based is a programming language. Okay. Interpreter-based languages are scripting language. Compiler-based called as programming language. Scripting language and programming language. Scripting and programming. So interpreter-based language are scripting language. Example. Scripting language examples. See that examples. Example: Python. Next HTML. Python, HTML. Scripting languages. Python, HTML, JavaScript. JavaScript also scripting language. Okay, JavaScript. JavaScript is not a Java. JavaScript different, Java different. JavaScript is not a Java. JavaScript is not a Java. JavaScript is different, Java is different. Like Python, HTML, JavaScript. Yes, next. Yes, PHP scripting. Okay, next Perl scripting. Yes. Next Linux shell scripting. Scripting language. Okay. Yes, compiler. Example, compiler programming language examples. Yes, C language, C++. Next .NET C#. They are compiler based. Okay, so these are interpreter based language examples. Yes, next compiler based example. These things here. Yes, what is Java? Yes, we should discuss about Java also. The Java, is it interpreter based or compiler based? Yes, we'll discuss now. Wait for a minute. In the next minute we'll go to Java. Okay. See, interpreter based language don't have exe files. Simply here interpreter. See, interpreter. Yes, interpreter based language don't have exe file. See, interpreter based language don't have exe file. Interpreter based language don't have exe file. See, compiler based, here everything is exe file. Without exe file, no, it won't execute. Compulsory to create exe file. So everything is an exe file. So these are difference between interpreter and compiler. See, interpreter checking code line by line, but compiler is top to bottom all the lines. Interpreter checking only one line at a time, but here compiler all lines. Okay. Next, interpreter generates output line by line. Compiler at a time output, because exe file executing at a time. That exe generating at a time executing. So at a time outputs. Okay, right? Yes, interpreter. It shows only one error. Interpreter shows only one error. It's only one error. Interpreter shows only one error. It's only one error. But compiler shows all the errors from top to bottom. Okay. Yes, interpreter is only one error. If any error comes, interpreter stops. If any error comes, interpreter stops. Any error comes, interpreter stops. But compiler is not like that here. Yes, it shows all the errors from top to bottom. Checking first line, next line, any error comes, error at some line, next line. So it shows all the errors. So next, here interpreter does not generate exe file. Yes, compiler generates exe file. Yes, interpreter executes source code directly. It executes source code directly. Compiler, it executes exe file. Yes, interpreter, it executes source code directly, but compiler executes exe file. Okay. Yes. So interpreter based, these are scripting languages. Interpreter based, these are scripting languages. Yes, compiler based, these are programming language. Compiler based programming language. Okay, interpreter based is a scripting language. Compiler based is a programming language. Yes, these are scripting language examples. Here. Okay. Yes, compiler. Yeah, they are compiler based. Yes, programming language examples here. Scripting languages and programming languages examples here. So these are interpreter based language examples here. These are compiler based language examples here. Right? Okay. Yes, interpreter based language don't have exe file. Simply conclusion here. Interpreter based language don't have exe file. 1 second, just a minute. See, interpreter based language don't have exe file. See, interpreter based language don't have exe. Here everything is exe file. So that's the difference between interpreter and compiler. Yes, now let us start Java. What is Java? What is Java? Yes, is it compiler based or interpreter based? Let us see about Java. Yes, about Java. Let us start Java. Yes, 1 second. Compiler. Yes, is it interpreter based? Yes, see, compiler based exe file generates that exe file executing directly. Exe file generated that exe executing directly. But interpreter based line by line, converting then execution, converting execution. Okay, obviously that exe file is faster. Okay, exe file already prepared file. Already, yes, binary code, that binary code directly executing. But interpreter runtime, what happens here? Runtime converting into binary code, then execution. So conversion time required, right? It has to convert. So that interpreter has to convert source code to binary code. Source code to binary code. Runtime. Runtime only this is. Runtime happens. So taking some time. Interpreter will take some time to convert into binary code. Interpreter will take some time to convert into binary code here. But compiler already converted code, right? Completely binary code converted. That executes faster. So obviously, in yes, compiler based that exe file is faster than yes that interpreter based scripting language. Okay, so compile is faster than exe file. Correct? Yes. So compile is faster than interpreter here. So because of exe file, that exe file executed directly. Okay. So compile is faster compared to interpreter here. Compile is faster. I think clear, right? So compiler based program executes faster than interpreter based program. Compiler based program is exe file. Since is exe file, compiler based program executes faster than interpreter based program. That's it here. Now Java. Let us come to Java. Java is it interpreter based or compiler based? Let us say about Java. Java is it compiler based or interpreter based? Java compiler based or interpreter based? Let us say about Java here. Yes. See, before going to Java, see except Java in other languages, except Java in other languages, except Java in other languages, what happens here? Except Java in other languages, what happens here? See, so first of all, source code converts into binary code. Source code converts into binary code. Okay, except Java in other languages, source code converts into binary code. That binary code given to processor. Okay, finally generating output. Okay, yes, except Java in other languages, except Java in other languages, source code converts into binary code. That binary code given to processor, finally generating output here. Source code converts into binary code given to processor, generating output here, right? Yes, except Java other language, maybe C language or C++, Python or PHP or shell scripting, any case, any language, take any language. Yes, any language in the software except Java in other language here, source code converts to binary code, that binary code given to processor, finally generating output here. Okay, source code to binary code. Yeah, this is by either interpreter or compiler. Yes, either interpreter or compiler. Okay. Yes, suppose C language compiler, C++ compiler, Python interpreter, HTML interpreter. Okay, right? So here interpreter or compiler convert source code to binary code, then given to processor, generating output. So this is a case of other languages. Yes, in Java what happens? Let us see. In Java what happens here? Java Java, what happens here? In Java, what happens? Yes, Java, yes, source code converts into bytecode. Source code converts into bytecode. Source code converts into bytecode. In Java, what happens here? Source code converts into bytecode. Source code converting into binary code. Sorry, source code converts into bytecode. That bytecode converts into binary code. Bytecode converts into binary code. Bytecode converts into binary code. That binary code given to processor, given to processor, given to processor, given to processor. So processor finally generating output here. Okay, see, source code converts into bytecodes. That bytecode converts into binary codes. That binary code given to processor finally generating output here. That's it here. Okay, yes. Source code to bytecodes. Yes, here bytecode introduced in Java. See, in other cases, only one step. Source to binary code directly here. Source code converting into binary code directly. In other language, source code directly converting into binary code. Source code directly converting into binary codes. But in Java, what happens here? Source code convert into bytecodes. Okay, that bytecode converts into binary codes. Okay, so you can Java, this is a intermediate code introduced here. One more code, bytecode introduced. Bytecode introduced. Bytecode introduced. Yes, in Java some intermediate code. Bytecode introduced here. So why bytecode here? Yes, to make the Java is independent platform. Yes, in Java bytecode introduced. In Java bytecode introduced to make the yes Java bytecode introduced to make the Java is independent platform. Yes, why bytecode introduced in Java to make the Java is independent platform? Okay, we'll discuss that point. Also discuss how Java made us independent platform. I'll explain clearly. If the topic also discuss. Okay. Yes, in Java, what happens? First of all, source code to bytecode to binary code. Yes, two stages, two steps here. It's a two steps. First step is source code to bytecode. Second step is bytecode to binary code. So first step is source code to bytecode. Second step bytecode to binary code. Two steps. It's a two steps. It's a two steps. It's a two steps. So it's a two steps, right? Okay. Yes. Other language only one step. Only one step. Yes. Let us see here. Source code to bytecode. Yes. Source code to bytecode. This is conversion. This is conversion by the Java compiler. Java compiler by Java compiler. Java compiler. Source code to bytecode. Source code to bytecode by the Java compiler. Source code to bytecode. Source code to bytecode by the Java compiler. Source code to bytecode by the Java compiler. Java compiler. Okay. Next, bytecode to binary codes by the Java interpreter. Bytecode to binary code by the Java interpreter. Java interpreter. Java. Yes, interpreter. Java interpreter. Okay. Yes. Source code to bytecode by the Java compiler. Bytecode to binary code by the Java interpreter. Okay. Let's see. Let me show practically. Let us see practically. Let us see one example, practical example. So D drive, test folder. Yes. One second. Why this came to here? Yes. Test folder. D drive test folder. Yes. Let us see one Java example here. Sit cmd command prompt. Command prompt. Yes. D colon D drive cd test directory. Okay. Here. Yes. Here test directory contains nothing here. No files, nothing. Okay. Yes. Notepad. Notepad. Test.java. Using Notepad, I'm writing. Of course, Java programming daily class using Eclipse. In daily class, always using Eclipse only. Daily class using Eclipse only here. Yes, for understanding purpose, just I'm using Notepad. Understanding purpose, just I'm using Notepad. Yes, Notepad test.java. Notepad. Yes. Do you want to create a file? Yes. Now here, see public class test. Public class test. Starting ending. Public class test, starting ending. 1 second, just a minute. Hello. Hello. Good morning. You tell me. Okay. Yeah, I'll call back within half an hour. Okay. Yeah, definitely. I'll call back. Okay, just currently in class presently. I'll call back in half an hour. Okay. Public class test. Yes, public right main. Yeah, that once again. Just I'm explaining one example in Java. Okay, Java installation not completed. How to install Java? How to install Eclipse that not complete? The topic is Monday topic. Monday we are going for Java installation. Okay, Monday Java installation. Monday Java installation and Eclipse setup. Okay, right? Is it clear? Okay, Sangeeta, Monday I will explain that. See, in my system already existing setup is there, so just I'm explaining one example to understand what is happening in Java. Okay, Monday class, Java installation, the Eclipse setup. So don't worry, Monday class we'll discuss. Okay, see public static void main. Yes, string square bracket box, string box. Yes, system dot out dot println, system dot out dot println system dot out dot println. Yes, hello world, hello world, hello world, hello world. Save. Public class test. Public static void means string square bracket arcs. Yes, hello world. Save. Okay. CLS. DER. Okay. Yes. Now let us compile it. Now compiling tester series. Test.java. CLS clear screen DER. See test.java 9am, right? So this file created 9am. Okay. Yes, Java C test.java. Java C test.java. Yes, compiled series. Tested dot plus file. Tested dot plus file generated. So tested dot plus file generated. Yes, now run it. Java tested. Run it. See. Now what is happening? Hello world output, right? Hello world output. So what is happening? See. So first notepad. Yes, notepad. Notepad tested.java. Notepad test.java. Okay. Notepad tester. So this is tested.java file. Test.java file. Test.java file source. This is source code. This is called as source code. This is called as source code. It's a source code. It's a source code. It's a source code, right? This is source code. Yes, source code. It's a test.java. Test.java. Source code test.java. Okay. Now this test.java given to Java C means Java compiler. Here it is Java compiler. Java C. Now see Java C test.java. Java compiler, right? Java compiler checking a test.java. Checking for errors here. Yes, here no errors. Here the dot class file generated. Okay, no errors. The dot tested dot class file 91am just now generated. Dot class file generated. Dot class file generated. Dot class file generated. Okay. So what's happened here? Source code test.java given to Java compiler. Test.java given to Java compiler. The Java compiler checking all the errors from top to bottom. Checking all the errors from top to bottom. Checking all the errors from top to bottom. If no errors, generating dot class file. That is called a bytecode. It's a bytecode. It's a bytecode. It's a bytecode. Bytecode. Tested dot classes. Tested dot class. Bytecode. So source code test.java. Yes, source code test.java is given to Java compiler generating bytecode. Java compiler is checking all the errors from top to bottom. If no errors, generated one dot class file. Dot class a bytecode. It's a bytecode file. It's a bytecode file generated. bytecode generated. Bytecode generated. Okay. Yes, then bytecodes. What happens here? See here, test.java is a source code. Source code given to Java compiler generated one test.class file. It's a bytecode file. It's a bytecode file. Right? Bytecode file generated. Now this bytecode file executing. Yes. Enter key, right? Now what is this? It's a Java interpreter. This bytecode file executing by the Java interpreter. Bytecode file executing by the Java interpreter. Okay, right? Yes, now here this bytecode file given to Java interpreter, Java interpreter, Java interpreter, Java interpreter, Java interpreter. So bytecode given to Java interpreter, right? Now Java interpreter taking that bytecode file, converting into binary code. That's binary code. Converting to binary code. Converting to binary code. That binary code given to processor. So processor that will be given to processor. Processor generating output here. Processor processor generating output. Processor generating output. Processor generating output. That's it here. Okay. See what is happening here. So first step, source code to bytecode by the Java compiler. So this is first step, Java C. Yes, Java C. Java C test.java. So this is compiler part. This is compiler part. Okay, source code to bytecode. Okay, next bytecode to binary code by the interpreter. Now program execution by the interpreter. Okay, yes, right, program execution. Okay, so what's happened here? What's happened Java here? Source code to bytecode by the Java compiler. That means yes, here in Java, yes, compiler, yes, compiler, yes, compiler checks for errors. Compiler checks for all the errors. Compiler checks for all the errors, all the errors, all the all the errors from top to bottom. All the errors here and generates dot class file, generates dot class file, generates dot class file, generates dot class file, generates dot class file. See, compiler checks all the errors and generates dot. If no errors, yes, if no errors, yes, if no errors, generates dot class file. If no errors, generates dot class file. Okay, right? So errors checking by the compiler. In Java, errors checking by the compiler. In Java, errors checking by the compiler. Okay, after generating dot class file here, program execution, the dot class, Java program with the dot class file, Java program dot class file, executing by the interpreter, executing, yes, execution by executing by the interpreter, executing by the interpreter, execution by the interpreter, executing by the interpreter, executing by the interpreter. Okay, Java program dot class file, Java program dot class file executing by the interpreter. Java program dot class file executing by the interpreter. Java program dot class file executing by the interpreter. That's it here. So what is happening here? So compiler checking for the errors checking by the compiler. Yes, actual program executing by the interpreter. That's it here. Now Java depends on what? Is it compiler or interpreter? Now you have to decide it. I have explained about Java. Just very clearly explained about Java. Now tell me here. You guys tell me. I have explained very clearly. Okay. About Java explained very clearly. Yes, Java depending on what? Is it compiler or interpreter based or both here? Java depends on what? Is it compiler based or interpreter based or both? Tell me what you understand from this.
Both.
You understand? Yes, it's a both, right? It's a both. Okay. So here see first compile involving. See first of all compile involving at runtime interpreter involving. So runtime interpreter involving. So Java depends on both compile as well interpreter. Java depends on yes both compiler as well interpreter. Java depends on 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 both compiler as well interpreter. Right? Okay. Fine. Just one second. Let me have some. Yes, Java depends on both compiler as well interpreter. Java depending on both compiler. Java depends on both compiler as well interpreter. That's it here. Java depends on both compiler as well interpreter. Okay, right? Yes. Now here, see one more thing here. Some question for you guys. Some question. Can we create exe file in Java? Yes. What you understand from last explanation? Can we create exe file in Java? Yes, in Java program expression, have we observed anywhere exe file? Yes, in Java program explanation, Java program explained, right? Java program explained. So first test.java
No,
dot generate one dot class file. Have we observed any exe file? No, no exe file in this. Exe file, no exe file. Okay, dot class file is not exe file. Dot class file is not exe file. No, we can't. No, there's no exe file concept in Java here. No exe file. Yes, no. Yes, can we create exe file in Java? Okay, yes, there is no concept of exe files. Yes, but there is no concept. There is no concept. There is no concept. There is no concept of exe files. There is no concept of exe files in Java. Exe files in Java. There is no concept of exe files in Java. See, once again, I'll tell you one more. Yes, example. See, any language, any language, any language, any language program, any language program, any language program execution, any language program execution, any language program. See, any language program execution by the interpreter, program execution by the interpreter, any language program execution by the interpreter, any language program execution by the interpreter. Yes, don't have exe file concept. Exe file don't have the exe file. Don't have exe file. Interpreter based language don't have exe file. Previously we discussed it. Interpreter based language don't have exe file. So any language program execution. See, any language program execution by the interpreter, don't have exe file. Okay. See here, since Java program execution by the interpreter. Since Java program execution by the interpreter don't have exe file. Don't have exe file. Don't have exe file. Don't have exe file. Yeah. Since Java program execution by the interpreter, don't have exe file. That's here. Java don't have exe file concept. Java, yes, don't have exe file concept here. Java don't have exe file concepts. Exe file concepts. Okay, next in Java everything is dot class file. In Java everything, yes, everything is a dot class file. Java everything is a dot class file. Java everything is a dot class file. In Java everything is a dot class file. In Java everything is a dot class file. Everything is dot class file. In Java everything is a dot class file. Java everything is dot class file. But dot class file is not exe file. Dot class is different, exe different here. Dot class exe file differences we'll discuss next class. Okay. So Monday class installation Java and Eclipse installation. After that we'll discuss about exe file dot class files. Okay. So dot class file is not an exe file. Dot class is not an exe file. Dot class is not an exe file. Okay. Dot class not an exe file. See, exe file is a binary code file. Exe file is a binary code file. Exe file is a binary code file, and it's a system understandable language. System understandable language. It's a system understandable language. System understandable language. It's a system understandable language. See, exe file is a binary code file. Exe file is a binary code file. Exe file is a binary code file. It's a system understandable language. Okay, correct? Yes, dot class. What is dot class file? Dot class file is a bytecode file. Is a bytecode file. Dot class file is a bytecode file. dot class file, dot class file is bytecode file, and it is a JVM understandable language, JVM understandable language. Okay, dot class file is a bytecode file and it's a JVM understandable language. That's it. Okay, so that's all about Java introduction. Java depends. Yes, now simply conclusion finally here. Java depends on both compiler as well interpreter. Okay, Java program error checking by the compiler, source code to bytecode by the compiler, program execution by the interpreter, bytecode to binary code by the interpreter. There are two things involving in Java, compiler as well interpreter. So Java depends on both compiler as well interpreter. That's it here. Okay, one second. Let me show your class document. Yes, your class difference between interpreter compiler. Yes, all these points explained very clearly. Difference between interpreter and compiler. The differences. All the differences. So all the differences very clearly is there. Okay. So main difference, fourth and fifth. These two are main differences. These two are main differences. Okay. Yes, exe file. Okay, interpreter exe file, it executes source code here. Compiler. Yes, if no errors, it generates exe file. It executes exe file. Is a main difference. Okay. See, Java depends on both the compiler as well interpreter. In Java, errors checking by the compiler. Yes, if no errors, then Java compiler generates dot class file. Dot class file is not is a bytecode file. See, Java runtime by the interpreter. See what is happening in Java. Source code to bytecode file. Okay. Yes, bytecode to binary code. Okay, right? Yes. Then finally generating output here. Source code, bytecode, binary code, processor, then output. Same what we discussed. Source code to bytecode by Java compiler, bytecode to binary code by the Java interpreter. So Java depends on both compiler as well interpreter. Java runtime is interpreter based. See, any language runtime is interpreter based, no exe file. Any language runtime is execution. Okay, since Java runtime is an interpreter based, no exe file concept in Java. Okay, can we create exe file in Java? No, there is no concept of exe files in Java here. Okay, yes, in Java everything is dot class file. Dot class file is not an exe file. Okay, right? Exe file is a binary code file. It's a processor understandable language. Okay, right? Dot class file is a bytecode file. It's a JVM understandable. Next, one more thing, exe file is OS dependent. Dot class is independent of OS or flat OS or platform. Anyone you can say here. Okay, right? Yes. See, exe file is an OS dependent. It's a OS dependent. Exe file is a OS dependent. Dot class file is independent of OS. Independent of OS. So that's all about Java introduction. Okay. Yes. So next class about Java installation. Yes, how to install Java. Java installation steps, Eclipse setup, and writing programming. So Monday, yes, we'll start programming. Monday starting programming. Yes, with this, all the introductions completed. Yes, we'll go for Java setup on Monday. Yes. Any doubts? Yes, case. Any doubts?
So one doubt, Java is independent language. Hello.
Yeah. Yeah,
So that
Java is
compiler, that
yeah.
dot class file, we can execute any system like Windows, Mac,
Yeah.
any
Yeah,
system,
any
right?
system.
So
Yeah, independent platform.
similar.
The topic I'll explain on Monday clearly. How Java
Okay,
made us independent platform. How Java made us independent platform. Yes, for that there is a dynamic linking concept. Okay, about dynamic linking concept we should discuss. Yes, we'll discuss on Monday that topic. Okay, right?
okay.
How Java made us independent platform. How Java made us independent. How the dot class file made us independent platform. The topic we'll discuss on Monday. Okay. Yes. Get the topic minimum 1 hour class. The top minimum 1 hour class Monday I'll explain. Yes. Still any doubts? Yes, case, any doubts? Yes, if no doubts, yes, let us wind up session for today. Okay, session, let us wind up. Yes, next we'll go Monday. So Monday, I think maybe link changing, will inform you link. I'll share you link. Okay. Yes, I'll share that link. Yes, that link I'll share in WhatsApp group. Okay, as well share in your Gmail ID. Okay, yeah, yes, that's all. That's all for today. Thank you guys. See you on Monday.